All right, good morning. Today I'm going to quickly review how to factor by GCF. This should always be your first step when you are factoring anything. If the directions say factor, you should be like, is there a GCF? And then do that. I'm going to show you up here the long process way that we showed you guys during class. And then when I do these down here, I'm going to do them kind of the way I do them normally. So in class, what we did was we kind of broke down our two terms. This is one term, this is another term. So we broke it down into prime factors. So we said 12, is factors of 12 could be 2 and 6. Okay? 2 is a prime number and 6 is 2 times 3. So those are the prime factors of 12. So we have 12, x to the fifth, y to the third, which is 2 times 2 times 3, 1, 2, 3, 4, 5 x's, and 1, 2, 3 y's. X to the fifth, 5 x's, y cubed, 3 y's. And then the 2 times 3 is 12, prime factored. All right, we're going to do the same thing to the 15. So 15 could be 3 and 5, and both of those are prime. All right, so down here we have our second term, 15 x to the eighth, y to the fifth. 15 is the same as 3 times 5. We have 8 x's and 5 y's. All right, so the way that we did this in class is we kind of put together the things that are the same, the greatest common factor. So any that they both terms have, would go together. So both terms have this 3. Okay, so for the GCF, we're going to have a 3 because they both have a 3. Okay, now they don't both have 2s, they don't both have a 5, but let's check out the x's. We have 1, 2, 3, 4, 5 x's in common. So x to the fifth power. Okay, and y's, we have 1, 2, 3 y's that they have in common. So y cubed. All right, this is the GCF. To factor by GCF, what you're really doing is you're taking that, let me write with a different color, 3x to the fifth y cubed, and remember, we put into parentheses what we had left. So here's the minus, there's the minus, and we still have 2 times 2, which is 4. So 4 will go there. For our second term, we have 5, 1, 2, 3 x's, and 2 y's, y squared. All right, this is the answer. This is factored. Remember, factoring is basically reverse distributing. What did we distribute into this in order to have that? Okay, hopefully that rings a bell to those of you that were in our class. It's a long way to do it, but it works every time. So you kind of get your GCF, find what they have in common, and then the leftovers go in the parentheses. All right, so that's the long way. I'm going to show you how I do this, and maybe that will help. I'm going to factor by GCF, so I know I'm going to have something here, parentheses, a term plus another term, because this had 2 terms. And I'm going to do that same step for this one too right now, just to show you the difference. We're going to have our GCF, but this time we're going to have 3 terms. Okay, I hope that you can see why I did that. I'm going to highlight just to hopefully make that a little clearer. Okay, and for both of these, this first part is going to be the GCF. Okay, so for this one, I'm going to look first at the number part. We have 5 and we have 40. When I do this in my head, I'm like, oh, I can divide 5 by 5. Can I divide 40 by 5? Yes. Is there anything bigger? No. So part of my GCF will be 5. Now we need to look at the variable part. Here we have n squared. That means that there's 2 n's. Here we only have 1 n. That means in both terms they have at least 1 n. Okay? And now I look at it and say, okay, what would I multiply 5n by to get 5n squared? Well, I need another n. Okay, and you can see if we distributed, we'd have 5n squared. What do I multiply 5 by to get 40? 8. We have an n. There's an n. So we have enough n's now. So this is done. This is the answer. Factored by GCF. All right, let's look at the next one. We have 36, 8, and 20 as our coefficients. So we're going to look and see what is the GCF of those. You can do it this longer way with prime factoring, or you can do it in your head. So I kind of look at it like this. Okay, 36. I know I can divide 36 by 6. Can I divide 8 by 6? No. Okay, so that doesn't work. Can I divide 36 by 2? Yes. 8 by 2? Yes. 20 by 2? Yes. But is there something bigger? Well, yes, there is. I can divide this by 4. 36 divided by 4. Can I divide 8 by 4? Yes. Can I divide 20 by 4? Yes. So maybe that's it. Let's see if we can think of a bigger number. 8. Can we divide 36 by 8? No. So then our biggest is 4. Okay, and this is the way it goes in my head when I'm doing it. It's kind of one of those things that you need to do it a lot and make a habit out of it. Otherwise, this way up here is faster. All right, now let's look at our variables. Each term, all 3 terms have x, so we know we're going to need some amount of x's. This one has 5, this one has 4, and this one has 3. That means every term has at least 3. All right, so this is our GCF, and now we need to figure out what do we multiply this by to get these numbers back. So 4 times 9 is 36. We have 3 x's, but we needed 5, so we have to have 2 more x's. All right, 4 times 2 is 8. We have 3 x's, but we need 4, so we're going to have 1 more x there. That's a total of 4. And lastly, 4 times 5 is 20. We have 3 x's. We needed 3 x's, so we don't need any more. So this is the answer, factored by GCF. All right, I hope one of those 2 methods makes sense to you and rings a bell. Otherwise, look at your notes or look for other videos if you'd like. Have a wonderful day.